Hello everyone, let's look at minimized maximum of products distributed to any store. So we are given an integer n and there are n retail stores. We have m products, product type, uh, and the quantity of each product is described in a quantities array. So we need to distribute all products, and a store can be given at most one product type but can be given any amount of it. So that means each store will only have one kind of product, but they can have different kinds of quantities. Okay, so what we have to do? We have to minimize the maximum number of products that are given to any store. Okay, so what we want is uh, the maximum number of products that the store can have, it should be minimum. What does it mean? Let's look at an example. So we have n equals to 6. That means we have 6 stores and we have 2 products. The quantity of product 1 is 11 and the quantity of product 2 is 6. So that means let's call it P1 and let's call it P2. So that means each store can have either product P1 or product P2, and we can give a store any number of amount of a particular product. Also, it is also possible to give 0 product to a store. Okay, and we want to minimize the number of products that a store can have. So one optimal way for this, so let's say we have 11 and we have 11 quantity of product 1. So what we can do is we can give 3 amount of it to store 1, 3 amount of it to store 2, 3 amount of it to store 3, and remaining 2 amount to store 4. And we have 6 quantity of product 2, so we can give 3 amount to store 5 and the remaining 3 amount to store 6. So now, so what's the maximum of this? 3 comma 3 comma 3 comma 2 comma 3 comma 3, and that is 3. So that means no matter in what way you distribute these products, a store would have a minimum of 3 products. So we want to minimize this quantity, we want to minimize this product. So whenever there is a minimum of maximum, where there is a minimum of maximum or maximum of minimum, so it's a standard binary search problem. And so whenever you see something like this in the question, try to think along the ways of binary search. Okay, so how can binary search help us in this question? Okay, so we can give, okay, let's see. So binary search, in binary search we have low and high. So how to associate these? So in this type of question, generally we do binary search on answer. Why? Because in the minimum of maximum or the maximum of minimum problem, generally our answer is constrained. That is, our answer lies between two quantities. So our answer will lie in some range, and we need to find this range. Okay, let's say if we can find this range, this lows or high or not. So let's say, since let's say the maximum, okay, it is if you look at the constants, you will find that uh, the product type, that is length of quantities, that is the, let's call this m. So m is always less than equals to n. So that means it would never occur that we may have to give a store more than one product type. Okay, so that means each store can have at max the maximum amount of that product available. So what I mean by that is, let's take this example. We have P1 11 and P2 we have 6. So if you want to distribute it in the worst possible way, we can give 11 of p1 to store 1 and 6 of this to store 2 and remaining 0. So that means this maximum would be 11. Maximum of this would be 11. So that means the uh, the highest value of this will be the maximum of the quantities array. So that means our h would be the max of quantity arrays. And what would be the lowest possible value? So let's say we would have let's say we would have only one quantity of each product type. So that means our distribution would something like 1 1 1 and remaining would be 0. So this is the lowest value that can be achieved. So our low is 1, our high is this. Okay, now we know that our answer, it lies between 1 and, for now let's call this mx. Our answer lies between 1 and mx, or in this question it's 11. So let's take this example only. Our answer lies between 1 and 11. Now what we do in binary search, we find the mid value. So mid would be 11 plus 1 by 10. So 11 plus 1, 12 by 2, that is 6. Now we have to check whether the answer of 6 is possible or not. And how would we do that? Okay, for now so let's say we will check it. But now, oh, for now let's assume we know the answer of 6 is possible. Okay, then what would we do? So our algorithm would something like this. We are doing while low is less than equals to high, we are finding the mid value, low plus high by 2, and now we are checking if this answer is possible or not. If mid is possible or not, and let's say we know if mid is possible, then we will do something, otherwise we will do something. So if mid is possible, that means there is a way we can distribute items to the store such that the maximum quantity of any product that the store can have is 6. Okay, so that means we have one answer of this. So we have one answer of this minimum of maximum problem to be 6. And since we want to minimize this, so if you want to minimize this, we want to go towards a lower value. So let's say this is our low and this is our high. This is one possible answer and we want to minimize it. So where would we go? Obviously we would reduce our search space to lower side. So that means we would set high to mid minus 1. So if this is true, then we would set answer to be mid and high to be mid minus 1. And if it's not true, that means there is no distribution possible such that the minimum of any quantity that a store can have would be 6. So in that case we would just set low to be mid plus 1. Now we would search for answer in this search space. Okay, but how would we check whether this is possible or not? Okay, so let's see. Now we want to check whether a particular answer is possible or not. And how can we do that? So let's say we want to check whether 6 is possible or not. So whether we can distribute products in such a way that the maximum amount of product that any store can have is 6. Okay, so to check this, why don't we do one thing? We have, let's say, 6 stores and we want that each store can have at most a product of 6. So why not just give 6 products to each store until you have no products left? Okay, so we have 11. So we have 11 quantity of p1, so we would get 6 to p1, so store 1. Then we would have 5 left, so now we would give 5 to store 2. So we would first give 6 quantities of the product and if the quantity of product is less than that, then we would give that amount of product. And for P2 we would only have 6, so we would give store 3 a 6, and remaining store we can give 0. So that means 6 is possible. And for this case our answer is what? Max of 6 5 6 0 0, it's 6. So that means there is a way we can distribute products such that the maximum amount of product that a store can have is 6. Okay, now since we know that 6 is a possible answer, now we would reduce our search space to, so we would set answer to 6, and now we will look for our answer in 1 to 5, that is low would be 1 and high would be 5. Now the mid would be 5 plus 1 6 by 2 3. So now we will check whether we can distribute 3 or not. So what would we do? We try to give each store a quantity of 3. So for P1 3 3 3, and now we would have 2 quantities of P1 left, and for P2 we would give 3 and 3. So it is also possible. So now we would set our answer to 3, and our low and high range would be 1 and 2. So its mid would be just 1, and now we will check whether giving the quantity of 1 is feasible or not. So we would give each product 1 quantities of P1, and no, it's not possible. We still have 5 of P1 left and 6 quantity of P2 left, and we want to distribute all products. So this arrangement is not possible. Okay, if this arrangement is not possible, we'd move low to mid plus 1. So now our low and high would both be pointing to this 2. So mid would be 2. So is giving the quantity of 2 possible? Why not to give it? So we are distributing 2 quantities of P1, and now we distributed all P1, but we still have 6 quantities of P2 left. So that means P2 is also not the optimal answer. So our optimal answer is 3. Now let's look at the algorithm. So we are setting low to 1, and we are setting high to the maximum element in the quantities array, and we are initializing answer to high because that's the maximum that's the maximum answer possible. And we are doing binary search here. So we are doing while low is less than high, we are finding the mid value, and we are checking whether this mid value can be the answer or not. If this mid value can be the answer, then we are assigning it to answer. And now we are reducing our search space to the left side, and if this is not possible, then we are just going towards the right side to search for the optimal answer. And this is our check function. So we are checking whether we can distribute the product or not. So we are initializing stores to 0, and here we are counting the number of stores required to distribute this amount of quantities to each store. And if stores is less than n, that means it's a valid answer. So what are we doing here? So we have n equals to 3, and so n equals to 6, and we have quantities 11 and 6. Okay, so now we want to let's say we are checking for 3. We are checking for mid equals to 3. So what we're saying is, to distribute P1, how many stores we need? We need a stores of this. We need 3 stores. And for distributing P2, we need how many stores? We need 2 stores. So that means we need a total of 5 stores. And how many stores we have? We have a total of 6 stores. So that means this is a valid answer. And that's all for this problem. Thank you.